Hello everyone, this is Heito Lessa. Thank you so much for tuning in on Twitch today. This is another episode of Build on Serverless. But this time we have Jason Barto once again, but now he's the one leading it. I'm not coding today, which is awesome too. So Jason, tell us what we're going to do today.
Sure. So a lot of the customers that we work with are starting to do more and more in the area of machine learning. And machine learning is notoriously data hungry. So a lot of customers are looking how to not only just feed data to their machine learning models and to their training processes, but also how to keep that data fresh, how to keep it up to date, and as a result of that, keep their models as accurate and as up to date as possible. So today what we're going to walk through is how to use some of the serverless capabilities within AWS, some of which have been discussed before in previous sessions, and some which I don't think we've touched on yet, to walk through how we can automate that process, how we can capture data from a source, modify it, engineer our feature set, publish it back out to S3, and then initiate a training job with using Amazon Stagemaker. And then after that training job, we'll have a model on the other side of it that we can then test and evaluate after the fact.
Awesome. So kind of sounds like we're going to use step functions to orchestrate the whole piece and Lambda to do some of the compute pieces.
Yeah, and absolutely. And one of my favorite services at the moment is AWS Glue. So a lot of customers are using EMR and Hadoop to run Spark jobs today. It's a great way to, in a distributed fashion, process your data sets. Mm-hmm. And AWS Glue offers customers the opportunity to run with basically a serverless Spark environment. So it allows customers to run Spark jobs, Spark ML, so you can do your ML workloads on there as well if you wanted to. Mm-hmm. And so we're going to be using that today as a way to scale out our feature engineering. The data set that we're going to be working with today isn't that large. It's, I think, the total size from, I think it's like 365 plus days of data. We're not going to be using all of that today, but even end to end, it's about 8 billion rows of data.
Oh, wow.
Which... yeah, but I mean, if you talk about petabyte scale, and there's a lot of customers working at petabyte scale, mm-hmm. Having a single machine try to crunch through all those numbers and do it in a timely fashion, it's just not going to work. So Glue and Hadoop and EMR are great ways to, again, distribute that workload, distribute that processing, and prepare that data for training. So we're going to use Glue as a part of that, overall step functions workflow today.
Okay, perfect. And what have you seen customers using Glue recently?
Sorry?
What have you seen customers using Glue for?
A lot of it is for that transformation. So that extract, transformation, and load, or even extract, load, transformation, depending on which order you like to do it in. Mm-hmm. And again, they're going to take the Spark jobs that they probably have running on-prem, either written in Python or written in Scala, and they can just hand that over to Glue and run it without having to operate the EMR environments that they previously would have been spinning up, running just the Spark job and then turning them back down. So hopefully it saves customers both time and money.
Okay, awesome. And we have a picture to have a quick look on what exactly we're going to build.
Absolutely, yeah, let's have a look. So put together a few charts just to kind of walk through the process of what we're going to build step by step. We're going to start with a data set which is hosted in S3 today, and we'll talk a little bit more about what that data set is in a moment. And we're going to create a very, very simple Glue job that is going to take those CSV objects that are being published and convert them over to Parquet and write them into a local bucket. So we're going to copy them from that source, put them into a local bucket, and then after we've done that first step, we'll then take those Parquet objects and kind of plus up our Glue job to then do feature engineering. So in between those two steps, the reason we're not going to write it all at once is we don't necessarily know what feature engineering steps we need to take yet with Spark. So we're going to spin up a Stagemaker notebook, dive into that and use that as a way to explore the data, right. Figure out how we want to modify it, what changes we need to make to the data, and prepare it for training. After we've done that in a Stagemaker Jupyter notebook, we'll incorporate that back into the Glue job so that we can start to productionize that flow.
Makes sense.
Once we've got that up and running, the next thing to do is then to start to begin to automate that. So we'll wrap a couple of Lambda functions around that are going to do simple tasks like starting the job and then monitoring the job. Mm-hmm. And this is so we can then ultimately wrap that entire process in step functions.
That makes sense.
So after step functions is going to do for us is this going to start the execution of that job, and then it's going to monitor the health of that job. And if it fails or if and or when it succeeds, it'll notify us of that.
That's why step function. So you can orchestrate when something goes wrong without having to do everything in your code.
Exactly, exactly. And then the next natural flow on from that, again, we're doing this for training purposes, is to have a couple of Lambda functions start a training job on Amazon SageMaker. So by doing that, Amazon SageMaker will deploy algorithms and create infrastructure that will then take that training data, train the model on it, and then we could even do additional steps. We're not going to do them today, but we could do additional steps to then test the performance of that model using that same data set in S3. Mm-hmm. So those two Lambda functions that we see hanging off of Amazon SageMaker are going to start that training job. And then they're also going to monitor the health of that training job, just like they're doing with AWS Glue. And again, all of this is going to be orchestrated by step functions, by a single state machine, so that when it concludes, when the state machine finishes executing, we should have a trained model on the other side of it that we can then begin to work with and poke and prod at and see how it performs, versus maybe what we have in production today.
That's awesome. Okay.
Then the last thing to do is, that's great, we've got step functions, it's going to do all of that work for us. We now have a kind of complex workflow built out, but we still need to execute that. We still need somebody to kind of push the button on that. And that's where CloudWatch scheduled events comes in. So we will schedule that to execute nightly as a job. And what that is meant to reflect is that every time new data gets published to that source database, that source S3 bucket, we can rerun step functions in an automated fashion. It'll automatically pull that data in, again, engineer that data set, and then retrain the model so that every morning when we come into the office, we've got a fresh new model waiting for us. And we can, again, hang additional automation off the back of that so that we can test that model. If it's more performant, maybe even do something like promote it automatically into production.
Cool. And how does the state machine look like? Here you go.
Glad you asked.
Actually, why next?
So this is not, I'm sure, the most complex step function state machine that anybody's ever seen. But the key thing I want to highlight here is that we've got primarily two activities, as we saw in the previous chart. We've got the glue job that we need to have run in order to do the feature engineering. And then we've got the SageMaker training job that we need to have run in order to produce the model. The main pattern that we're adopting here, as far as step functions is concerned, is this start, wait, check, and then revisit process that you see over here on the right-hand side. So we're going to start an activity, we're going to execute a Lambda function, and then we're going to just wait a period of time. Glue jobs, I think the one that we're running with today takes about 60 seconds to process through all that data. Equally, the SageMaker training job, I think, takes about 5 minutes. So we've incorporated a wait time into that, so we're not just constantly pinging that API, right? So we're going to wait about 60 seconds, check the status of the glue job, find out if it has failed, succeeded, maybe it's still running, and then kind of keep going in that cyclical method until the job has either completed or failed. And then we'll pop out of that and either move into training or we'll just error out and report it.
What I like about this approach is many customers were asking, even before SQS integration with Lambda, that they were doing something async, or actually some process, something somewhere would actually take probably a minute, sometimes 2 minutes, or even sometimes a day, which is actually bizarre, but it could take a day for something. And they wouldn't want you to wait for their inside the Lambda functions because, well, we were paying for that wait, right? And that step functions is perfect for this. When you're doing a wait, are you injecting a wait timestamp, or we are waiting for a particular, let's say, 2 hours, an hour?
So we've not got it hard-coded into step functions. Step functions has a fantastic capability for taking parameters and taking inputs and allowing you to modify those inputs as part of the flow. What we've got is that in the source event, in basically the state machine definition, the input to that, we put a wait time for each one of those steps. So we've got that in our parameters file. If we wanted to do this in a more advanced fashion, we could actually have that check transformation status, keep track of how many times it's checked in the past by putting that back into the state, and then modifying that wait time. And then we can reference that. And you'll see how we're doing that in the state machine definition when we get to it.
Perfect. Okay, what do we do next? Do we start the
project? Let's go ahead and get started. First things first, let's introduce the data set that we're going to be working with today. So I'm a solutions architect for anybody who didn't join us originally, and I work with a lot of financial services customers. So I'm very happy to be playing today with the Deutsche Börse data set, which is available in the AWS Registry of Open Data. This is intraday data, intraday trading data. That Deutsche Börse publicly publish into an S3 bucket. And you can see here, I think Hader's going to be sending out the link here in a moment. But you can visit the website, get links to the S3 bucket that they run and operate and that they publish this data to. and then begin to do exactly what we're going to do today, which is copy it over to a local bucket and start to explore it.
Awesome. I just sent the link to everyone else, or to everyone who just joined the chat. Just kind of send it again just in case. And if you actually take the register.opendata.aws, you can actually find even more data sets. So this is the one we're going to be using today, but feel free to actually take a stab at everything else. Everybody.
Cool. So with that groundwork laid down, let's go ahead and get started. Any other things that we should mention before we get in?
No, I think we're pretty good. I think we got a quick overview of the services. If you just joined right now, I've just actually sent you a text message on the chat explaining what we're going to be doing. We will revisit this in about 10 to 15 minutes. So
cool.
Let's kick off.
So let's get started with some of the groundwork. There's not a whole lot of groundwork to do, but in the interest of best practices, we are going to do things like creating a couple of IAM roles, giving ourselves permissions, and creating an S3 bucket. So let's start there. Let's start with our S3 bucket. We're going to create our very first data lake in the form of a single S3 bucket. So I'm going to call this Ireland data lake. And actually, let's make that a little bit more specific to us. Auto trainer.
Okay.
Ireland data lake. Lest we get a name clash. All right. Now we've got our data lake, if you will. Let's create some IAM permissions so that Glue, Lambda, Stagemaker, so they can start to read and write to that bucket. I'm going to create a role. And let's give it to Glue to start with.
Okay.
And let's call it, let's see, we want to give it the Glue service role. Well, actually, no. Sorry, let me back up.
So go to previous, or you want to create everything from scratch? Okay.
Yeah.
Actually, now.
I'm just going to create a policy. So the policy that I want to create is for that S3 bucket. And I want to give all actions to just that bucket.
Makes sense. So for those of you who are just tuning in right now, the reason we're doing all these pieces, the whole groundwork, is to make sure that the Glue can access the S3 bucket we just created, and every file, every data set, the whole data set we're going to be using, the Glue as a service can actually access that. Different from actually giving that role permission to a single IAM user, we're giving that actually to an AWS service.
All right, so I'm going to call this data lake full access. And that policy is going to grant anybody who has it attached to them the ability to read, write, and do anything they need to with that S3 bucket. Maybe a little bit too permissive, but at least it's locked down to that bucket for today's purposes.
Cool.
All right. Now, the first thing to do after that is to create the Glue job. So let's give that Glue job that we're going to create is going to need permissions like everything else. So let's go ahead and create that role that we started to create a moment ago, just for Glue.
In the meantime, you continue to go as you're planning to. If I remember correctly, Glue can need permission to access S3 resources, and also can invoke Lambda functions too. Or I could be wrong on that, on the second one.
So that's a fair question. What can you or can't you do with a Glue job? So a Glue job is Python code or Scala code, and with some exceptions, you can do pretty much anything that you can do with, say, a Lambda function. Mm-hmm. You've got network connectivity, you've got ability to access the API, you can attach it to a VPC if you need to, so you've got a lot of flexibility there. What I've done in the past is to make calls out to S3. I've not yet attached myself to, say, an RDS instance, but you could do that. I thought about doing that for today, but I gave it a miss in the end. But yeah, there's not yet too many restrictions in terms of, so one restriction versus Lambda functions. If you tried to bring, say, pandas to a Glue job, Glue today does not support Python modules that are C-based. So you can provide your own custom modules. You can even provide third-party modules as dependencies to your code. But if they've got a C library on the back end of them, that's not supported currently today.
Right. Okay. Okay, cool. Let's go. So next review, give it a name.
Yeah.
And then we can kick off on the coding piece.
Auto trainer, Glue service. All right, and that's got permissions to interoperate with Glue. It's got permissions to read to S3. And actually, I forgot to attach our new data lake policy to it. So let's do that. Attach policy, search for data lake. There we are, data lake full access, and attach that policy. Can everybody see this well enough? Is the zoom level about right?
Yeah, I'm just looking at it on the feed screen right now. Okay. So it looks relatively okay to me. So I will be fine.
Okay.
Right. As we go through step functions and everything else, then we can definitely zoom in.
Okay. So we now have the beginnings of, we've created some permissions, we've created some roles, we've created an S3 data, an S3 bucket that we can now copy that Deutschbörse data into. Let's now create the Glue job to do just that. So I'm going to go to the Glue console. Now, in actual production environment, I mean, today we're just kind of doing some development, just some experimentation. So I'm going to be doing a lot of work with the console, a little bit of work with my IDE. In actual fact, you probably want to use SAM or CloudFormation for actually pushing changes into the environment as you start to develop and evolve this. To talk about Glue a little bit in terms of how it operates, you've got three key sections. The databases you can have more than one database, and to that you're going to add tables. Tables are one or more objects that you've got in S3, and those can be discovered by crawlers in your environment. Those crawlers can either be customized by yourself in terms of what they look for and how they perform, or you can do what we're going to do today, which is just use one of the ones out of the box. And it'll recognize things like CSV documents, Parquet documents, Avro, I think, as well. A lot of the common popular data formats that are out there today. And it'll publish those into the Hive metastore, which is on the back end of Glue, and make that available. In addition to objects in S3, it can also scan databases that you've got in your environment, so RDS instances as an example. So you've got the ability to catalog those as well. In addition to crawlers in the databases, where we're going to be focusing on at the moment are the idea of jobs. And jobs, again, are those Spark jobs that you want to run in your environment to capture data, manipulate data. So we're going to be leaning on that pretty heavily today. And then after those jobs are completed, we want to rerun the crawler so that it rescans the environment and detects any new data that's been put into it. So let's get started. First, I want to create a crawler, as we were just mentioning a moment ago, and that crawler, we want to point it at our data lake.
By data lake, you mean the S3 bucket we created before.
Exactly. We're going to go with the default settings. We're going to point it at our data lake and hit select. Okay, so it's just going to scan everything in that bucket, regardless of the prefix. And those prefixes will have meaning, though, in terms of the overall tables that get produced as a part of that. And we'll see that represented as we get a little bit further into this. No, we're not going to add an additional data store. Yes, we're going to provide
an existing IAM role
policy.
Okay.
So there we've got an IAM role.
Which is interesting because he also creates one IAM role. Makes things easier.
We're going to go with run on demand. Equally, we could have that run in a sort of automated fashion, similar to what we're going to set up with CloudWatch events later on. We're going to have it write that data to a new database. And click next. So this is a summary of everything that we just configured. Again, taking a lot of the defaults here, and click finish.
One thing I liked about that when you're, can you zoom in a little bit just again? One thing I liked about that probably just one zoom should be fine. Here you go. Awesome. One thing I quite liked when you were creating the crawler, which I don't think is obvious for the first time for people who are seeing that now, you can select an S3 bucket in your account, the one that we are using right now, but you could also scan or crawl S3 buckets in another account. And that makes life so much easier in many ways.
Yep.
Especially because you likely want to have that data lake somewhere else.
Yep, absolutely. And one of the things to note is that one of the gotchas, if you start to explore, say, that Deutschbörse data set, is that they will publish data to their S3 bucket, even if it's only the header. That data is going to be in CSV format. So every record in there will at the very least have a header. If there's no rows of data to it though, the glue crawler will get confused. So one of the things we're going to be doing as a part of that glue job, we're not going to have glue scanning that Deutsch Börse data set directly. We're instead going to have it scan our local bucket, and we'll have the glue job first capture the data and do a bit of processing, do a bit of sanity checking. If it's an empty record, we're not going to copy it over. If there's data there, then let's bring it in and then we'll crawl it.
Nice. Okay. So what's next in there? We create the job.
Yep, so we've got our crawler, we've got our database. The next thing to do is to create our job. So let's say add job. Auto trainer.
Coming up with names is so hard. Every session we do, no matter how, even actually doing live demos on stage is actually always a struggle.
We'll call this one auto trainer.
No, not rent for sure.
We're going to give it that same glue service.
Mm-hmm.
We're going to tell it that we are going to author the script by hand, and my IAM session is just timed out.
Oh wow. Okay.
It is a live demo, folks, so that's the way it goes. Auto trainer, transformation, job.
Mm-hmm. Google service.
New script. We're going to use Python, not Scala. It's going to create whatever it is that we feed into the editor into S3 and store that in S3, store our script in S3. We're also going to define a couple of parameters. So as part of the execution of this, we don't want to hard code, values like the date. If you take a look at the Deutsch Börse data set, the bucket that they're using is partitioned by year, month, and date. And so we want to copy particular dates because when it becomes tomorrow, we don't want to copy the entire data set. We don't want to modify the entire data set. We've already done that work.
Mm-hmm.
So we just want to copy the most recent date. So we're going to have a parameter that gets sent to our glue job of date. And we're going to just set that as a default value of the 15th of August, just because. But on a day-by-day basis, and we'll see this in the CloudWatch event definition later on, we're going to provide it with the most recent date, obviously. This is just a default value. We're also going to put in source bucket, and that's where we want to put the Eurex. What is the name of that bucket again? Here we go. Target bucket. We called it Auto Trainer Ireland Data Lake. And then finally, crawler.
That dash, is that something that's more of a preference, or is that something that's needed?
It's needed. It's because of the way that Glue executes. These essentially get turned into command line parameters.
Right.
And so the dashes are required.
Okay.
What did we call our crawler? Auto Trainer Data Lake Crawler, I think. Trainer Ireland Data Lake Crawler.
Yes.
All right. Now, no connections at the moment. These connections are, Glue does its best to provide you with a bit of a point and click interface for some of the transformations. So if we're able to provide it with a source schema, again, maybe that Deutsch Börse data set, if we've had it scan it, as well as a target schema, it can start to do a lot of the mappings for us in a rather intelligent way. We don't have any of that information for it yet, so we're just going to go blindly and not actually let Glue help us.
Okay.
So we're going to save that job and edit the script. And let's get this a little bit larger.
It looks like it's just a normal plain Python script, except that we have AWS Glue library in there.
We do, yeah. And so
Nice
you've
problem.
got access to both the AWS Glue libraries and their transformations. We can see kind of buttons for the templates for those up here.
Mm-hmm.
You've also got access to just the raw PySpark as well. So we're going to be using a bit of a mix during the feature engineering, because in the notebook we're going to have access to PySpark. That's what we're going to incorporate back. For now, what we're going to be putting into this Glue job is just to copy and read the data using the Glue libraries from Deutsch Börse's S3 bucket into memory as a data frame. And then we're going to write that data frame back out, again, via those glue libraries as Parquet.
So, Jason, just before you continue, it sounds like we got a typo. I'm just trying to find out where people are saying there's a typo in auto trainer. You left out a T.
Ah, okay.
But I can't see in there. Maybe it was the crawler where if you, PS2 or, okay.
Let's have a look.
In the target bucket.
Okay.
So let's go in there.
Edit the job.
Thanks for helping out.
Indeed. Pair programming, it works.
Okay, so.
Yep.
Here we go. Awesome. The target bucket.
Well spotted.
Perfect. Yeah.
Send them a t-shirt. All right. Now, I've got to admit that PySpark and even glue jobs are not my first language, so if you don't mind, I'm going to pull a bit of a ripcord here and copy and paste some code, but I will explain exactly what that code's doing. So the first thing we need to do is to copy over the data from S3. And before we even do that, you'll see this param section under Get Resolved Options. Get Resolved Options is a part of the glue libraries, the glue module that gets incorporated into a glue job. So where we were specifying source bucket, target bucket, date, etc., we've got to put those in here just like you would if you were, say, using os.environ or similar. So let's put in date.
And by the way, Morgos, you're watching this live, and by the way, thanks for the heads up.
Source bucket, target bucket, and crawler.
Just to make sure people understand that this is live and this is not pre-recorded.
Okay, so happy with that, and then let's clean this up so it's maybe a little bit more readable. What we're going to be doing is using the glue context. This is very similar to a Spark session or a Spark context. And it's going to provide us with the way to read what's called a dynamic frame. If you don't have background in either Spark or Pandas, or even R really, dynamic frames are very, very similar to data frames. And it's a way of putting into rows and columns any data set that you can read with one of those libraries. And it provides us with a way to easily manipulate in a kind of two-dimensional fashion those data sets. So where today what we have is a collection of CSV files in the Deutsche Börse data S3 bucket. We're going to read those into a dynamic frame, which is slightly different from a data frame in terms of how it infers data types and how static those data types are for the individual columns. There's some great documentation on the Glue homepage about what exactly a dynamic frame is in comparison with data frames and how and when you might want to use them. What we're going to be doing today is leaving it as is for the simplicity and convenience of having basically 2 lines of code for copying and then writing back out the data. The important thing here with this create dynamic frame is we need to tell it to communicate with S3, and then we need to tell it where that S3 bucket is. So this is going to be args source bucket.
Makes sense now. The dash dash.
And actually, I think we better turn that into a source URI.
Okay.
All right.
Okay, so let me just send. Yeah, so just PS2 people apologize from our side for auto moderation. So it's something else you don't need to worry about, Jason. We accidentally just muted someone in the message. That was actually our fault. And yeah, Loburu, thanks for joining, by the way.
Okay. So that looks right. And that's going to basically create a path something along the lines of S3, your X, PDS, I forget the full name of the diff bucket. And then it'll be 2018-08-05. And what Glue will do on our behalf is then scan every object below that prefix.
Okay, so just double check one thing here. So I'm looking at the dive frame, create dynamic frame options. There's a path key and then args source S3 URI. Is that right? If you go back in there, you see that the path key at line 22.
Line 22, yep.
Yeah, so the args as source S3 URI, but actually that seems to be different.
Yep.
Yeah. Cool.
I've also got, let's just double click on my browser here.
If you also want to bring this up to Visual Studio Code or in IDE or Cloud9, feel free to do it. I think it's easier to spot some of those pieces. We definitely have people who are willing to help, but this is live. It's definitely something that's going to go wrong.
Right.
All right.
That looks better.
Here we go. Can you do a zoom? Zoom just one level. Awesome. Perfect.
Okay.
And feel free to hide that piece. Yes.
All right, so we've got our parameters being read in. We've got our source URI being crafted. Equally, we're going to need a target URI to be crafted.
And by the way, that / is not a Python comment, so that's going to fail.
Thank you.
This is the issue when we keep switching between languages all the time. I do that when I'm doing TypeScript or JavaScript all the time.
There we go. And we've captured the crawler. We've got the date where we want it. So I think we are okay. Again, when we read that data from S3, we're specifying that it has a format of CSV and that there is a header there so that it knows to strip that out and not try to treat that first line like it is a record of data. All right. Now, next thing to do is to write it back out to S3. Okay. So where before we were doing a create dynamic frame, we're now doing a write dynamic frame from, and we're going to pass it that dynamic frame. This is going to become more prevalent in the next stage, where after we've explored the data, we're going to begin to manipulate that dynamic frame. At the moment, it's just a memory reference. So we're going to be passing that back into Glue so they can write it to our target S3 URI, not our output S3 URI.
Yeah, I was going to say that again. I was like, whoops, that seems to be, yeah.
And we want to write it out as a format of Parquet. Okay.
So hang on, there's an issue in there. Glue context is red, line number 30. So let me see.
Glue context.
Yeah, so line number 30.
Ah, I see it.
There we go. Aha.
Right, now, in a very uncool way, we're going to now just copy and paste this back in. And click Save Job.
I think it's fine. There's no shame on that. We are merely prototyping.
Now, just to trial this out, I should mention too that while we're doing kind of this cut and pasting back and forth between the web console and our IDE, again, in a real life environment, what you probably want to do is take advantage of developer endpoints. Developer endpoints is something that the Glue service makes available that you can connect something like a Duplin Notebook up to, or you can even SSH into them and get an interactive REPL with Glue. So you can do this in a much more interactive fashion and experiment quite online with Glue. We're just not doing that today. So where we may have pasted this into a Duplin Notebook or even developed it in a Duplin Notebook and kind of execute and iterate on it interactively, today, in the interest of speed and time, we're just kind of chugging along, putting the code in, and now what we're going to do is test it by clicking Run Code, or rather Run Job. What that's going to do is it takes those default parameters that we specified earlier and keeps those in, but also gives us the opportunity to change those, which is what we're going to leverage later on when we start to script this. So let's click Run Job, and while that's running, what we'll do is we can see here, and that's actually not that easy to see with the zoom. Let's figure that out a little bit. So that's going to take probably about 60 seconds or so to run. While it's doing that, let's talk about the next step. So once this succeeds, the next thing to do is to go into Athena and start to query the data that we've copied into our local data bucket, our local data lake, if you will, our S3 bucket. And the reason for that is because we want to get a copy of the data out. Not all of it, but a sample, so that we can then drop that into our Jupyter Notebook and begin to explore it using pandas and even PySpark and figure out what our transformation logic needs to look like.
Awesome. Interesting. I saw that you can even have metrics on top of that. I'm looking at details, script, and metrics.
Absolutely, yeah. So we're kind of using this as a bit of a toy today. It's a learning mechanism. If we were using it in Anchor, we'd probably be doing very large distributed jobs. And so we would want to have information about the underlying instances that are running this. Similar to you would with Lambda, you want to know what your execution time is, what your RAM consumption is. And we've got that kind of information here using CloudWatch metrics, like with all things with AWS.
Right.
So that gives us a chance to kind of optimize, because the way that Glue is built, you are actually built by data processing units, essentially. So similar to Lambda, not quite one-for-one likeness, but it is very similar in terms of the more distribution you want for your Glue job. That's what AWS is going to bill you by. And so if you can optimize that, get as much power out of each one of those processing units, you're going to pay less and get more capability.
Awesome. Okay.
We can also preview the script if we wanted to just quickly check something. We can then edit the script if we see a misspelling or something similar. We can see the execution details for it. Let me bring this up a little bit. Great, so it has succeeded. The next thing to do is to actually add the crawler. So we haven't put that into our code yet. Let's just go ahead and run the crawler manually. So I'm going to click the crawler that we created, and I'm going to start it running.
And that's running on demand. Can I schedule a crawler?
Absolutely, yeah.
Okay.
They can run in an on-demand fashion using things like Lambda functions or triggers. Equally, you can have them run periodically every night or what have you, every hour if you wanted to. There's also with the jobs, today what we're going to be doing is using step functions to orchestrate. If we had multiple jobs, it would be orchestrating multiple jobs.
Right.
And actually there's a much larger, more robust source code base that's available on GitHub today. And I'm sure Hader we'll share that link with you later on if he hasn't already. And that is going to demonstrate the ability to orchestrate multiple jobs using step functions. Equally, if you didn't want to bring step functions into the fray, you could also take advantage of triggers as part of the ETL. And what triggers will do is allow you to, as one job concludes, another one will start automatically off the back of that, provided it was successful. So our crawler has now finished running. We can see that it took about 30 seconds to run, and it has added a table to our database. So let's have a quick look at the tables that it has added. We've got Auto Trainer Ireland Data Lake.
Classifications at Parquet.
Yes, if we wanted to take a look at it, so we could open it up. It'll tell us what the schema is for it, what classes were used to read that data in, write that data out. And then we can see here that it's done a lot of inference about the data types. Well, it's done some inference about the data types. And I think a lot of this is due to the way that we've kind of just rapidly read the data in and then dropped it back out as Parquet. When we read it in, it defaulted to reading all of those fields as strings or as objects from the CSV. In a real world, if this were an actual test, what it would have done is also then to cast those different values, those different columnar data types. We're not that worried about it at the moment, because when we do the feature engineering, that's kind of what we're going to take on. So we'll leave that for now. This is basically just giving us a raw copy in Parquet format instead of CSV. The reason for doing Parquet, if you're not familiar with Glue and Athena, they are going to be much more performant, and you're going to get much lower costs in S3 by storing data in Parquet, especially compressed Parquet. Parquet being a columnar data format means that when you go looking for particular columns or particular fields using Athena, and we'll do this in a moment, it knows exactly which S3 objects to go to, and it's also indexed in a range sort of fashion, so that it needs to query much less data in S3. So you're hitting S3 much less, and equally because it's compressed, you have you're taking up much less storage on S3. So you're going to get faster query times in Athena, and you're going to get less storage costs in S3. So it's really quite a win-win by keeping data in Parquet.
Perfect.
Right, so let's go back to our list of tables and go to action and say view data. This is going to pop us into Athena, and we'll be able to get a feel for just what data is in this table.
That is awesome. By the way, it's the first time I'm seeing this.
So let's just get a closer look. So we've got 10 rows of data here, and again, these were copied over just a moment ago from the Deutsche Börse S3 bucket. So we can see a lot of good data here for machine learning. It's going to require some cleansing. Machine learning algorithms aren't necessarily bothered about something as textual as EUR in terms of currency. But we're going to do a bit of transmogrification, if you will, a bit of feature engineering on this and prep it for linear regression, I think is what we're going to be doing today. Mm-hmm. So what I want to do is take a copy of that and drop it into our Stagemaker notebook. In order to do that, I want a lot more than 10 rows of data, so I'm going to ask it for 10,000 and hit run query on that.
What I find interesting about this is people sometimes don't realize most of the work on the machine learning pieces is at the beginning, it's all about filtering the data, cleaning up the data. And only after that, you actually start doing some of those nitty kind of things.
Absolutely, absolutely. So, and that's really, if you talk to a lot of people on Kaggle or professors who work in machine learning and data science, most, if not all of them, will tell you that the bulk of the work is actually in the feature engineering. Unless you're doing really hardy work in terms of developing, convolutional neural networks that have never been seen before, or developing new algorithms, or an ensemble of models that's never been constructed before. Unless you're doing that kind of advanced machine learning work in the algorithm space, really the most value is in doing the feature engineering and getting the highest quality, the most refinement out of your data for maybe a bog standard machine learning algorithm like linear regression. Mm-hmm. And it's kind of that old garbage in, garbage out adage, right? And that if your data is not cleansed, if it's not of a high quality, no matter how smart your algo is, you're just not going to get good predictions off the back of them.
Exactly. Okay, so here we are on the Stagemaker console. And you're going to create a notebook from scratch, or are you going to use an existing one?
I've got an existing notebook server. I'm going to access that in a moment and then create a notebook off the back of that, and I'll upload that CSV data that we just downloaded from Athena.
Right.
If we wanted to get super fancy with it, we could actually launch Boto 3 in our notebook and query Athena directly. I just didn't want to write that much code right now. So
that's fine.
For those who aren't aware, the notebook instances that are available on Stagemaker are hosted Jupyter notebooks, and this is your standard issue Jupyter notebook. You've got the ability it already has installed things like TensorFlow, MX, Net, PyTorch, a lot of those common frameworks, and you've got the ability to easily spin up and create different environments like R, Spark, and PySpark. What we're going to be doing today is just creating a Conda Python 2, don't say it, notebook in order to use pandas and use Spark to explore the data set that we've just downloaded from Athena.
I will actually let the audience, I'm sure someone who's actually watching will say it. If nobody says it, and then I can actually, say in the next 5 minutes.
So let's copy our data set and
Can you increase that a little bit?
Yes, thank you.
Assuming like probably twice. Okay, nice.
All right, so let's rename this. So Deutsche Börse data.csv. Cool. And we'll go back to here. So from PySpark import. Import. All right. There we go.
Let me just send a few things for people in the meantime. Nick, internship. We actually have a page, Nick, for jobs. I just want to have a quick look if you have one particularly for internship. We should, but I could go wrong. AWS internship. Let me have a look. Here we go. Let me send that over to you, Nick. We have a few. Yes, it is live. We're just a little bit quiet today. We're actually trying to type and trying to get these pieces right.
All right. So what we've done is just to load that CSV object up into a Spark data frame. This is slightly different from a pandas data frame. So what I'm going to do in order for the purposes of demonstration is actually have Spark convert that over to a pandas data frame. And then let's get a sample of the data.
If you've never seen DataFrame before, if you never worked with pandas DataFrame, here's the link for you. I'm just setting it over the chat, and have a quick look. It's actually very powerful. I actually love that data frames. And the first time I saw it was actually quite efficient. I used to do a lot of map defiltering pieces in Python. And then when I saw pandas, I was like, wow, can I simply clean the data like this?
Yeah.
And especially 3D data, I was actually quite impressive on the performance.
Yeah, and we were talking earlier about running glue jobs and not being able to upload the pandas library along with it. To be quite honest, I think that's actually a good thing. And the reason for that is, I and a lot of other data scientists have got a lot of familiarity with pandas. And as you mentioned, it has a lot of power, a lot of great capabilities, which is why everybody's such fans of it. But in terms of operating in a distributed capacity, it's not built for that. So it's almost, I kind of feel like it could be a bit of a crutch if we tried to use it in the wrong environment because we've got familiarity with it. So by almost forcing, if you will, if anybody's got familiar with languages like Haskell and kind of functional programming languages, literally pulling some of those capabilities that we know and love and have been raised on and forcing us to kind of do things in a more distributed fashion can actually be a painful thing at first, but a good thing in the end. So we've now got a sample of the data set that we've loaded up into CSV. Let's just have a quick look at exactly how big that is. And before we keep doing two pandas, let's just do pddf equals spark df.2 pandas. And let's move on, and then pddf dot shape. Actually, let's do info. So we can see that we've got 10,000 records. They've got 20 different columns. Here's the name of the columns. They've all been detected as objects. And what we need to now do is to start to transform those. So let's get into that.
Okay. All right, Nikki. That's kind of an interesting question. I would say that will be a bit of an unfair with other candidates. That's something else. You don't need to worry so much about, Jason. Feel free to carry on with your bit of programming. Nick, I would recommend you to have actually a portfolio on either on GitHub and one of those open source pieces that we do. Get a bit of an experience with open source as well. That helps a lot on the programming side. And get an experience before you join any companies in general, if you can. If you have any friends or any portfolios in place, you shouldn't have much of an issue in there. So I wouldn't see that as something crucial. All right, so we're selecting the piece. Let me have a look.
So where we've got 20 different columns at the moment, I want to pare that back a little bit. So if we take a look at how many columns we've got and what exactly sort of values we've got in there. Some of them we're not necessarily concerned with for today's purposes. So by running a select statement, it's kind of the inverse of dropping. So we're not going to delete them from the data set. we're just telling Spark that we only care about these 6 or these 7.
Okay.
And then we can have a data frame that just references those. Where that's important is that when we put this back into Glue, we're going to write that out as a very particular order in order for the linear learner algorithm that we're going to pass this on to in Stagemaker.
Okay.
So we've done a select on that. Let's now start to transform this. And what we need to do is to craft some new columns. So where we've got things like max price, min price, what we want to actually track and try to predict is what the percentage of change is in the next trading event. So for any one particular stock or symbol or security, we know that it has, we've observed it at time 0. What is it going to do at time 0 plus 1? So we're going to capture those columns that we've got there in terms of string and number and date columns. And then we're going to manipulate that, convert it over into a percentage, and then line up that percentage and that observation with the next observation in the order, in the time order for that symbol. So let's do that now, and then that will produce the overall training set, both the label and the observations that we want to train on.
Awesome. Yeah, I was about to say that.
So we want to subtract from max price, and this is what I really love about data frames is, we're going to put in a very simple mathematical expression here, and it is, when it executes, is going to, operate over those 8 billion rows of data if we ask it to, without even breaking a sweat, which is just awesome. Okay. So we've just created a new column called %change. And the next thing we want to do is, like I said, where at time 0 it has this value, and then at time 0 it's got, or time 0 plus 1, it's got another value. We want to take a copy of that next value and bring it up to time 0. Create the label column for all of our observations. Mm-hmm. In order to do that, we've got to give a date timestamp to every one of these. We've got a date and time, as you can see here, with these 2 columns. It's just detecting it as an object right now, which is not really useful for comparison purposes. So let's do a bit of modification on that. So in order to do that, we're going to need a couple of extra modules. So let's go into here and say from PySpark functions import. We're going to want to UTC timestamp. We're going to want concat. We're going to want lead, we're going to want lit, and we are going to want date format. Okay. We're also going to need from PySpark ml.feature. Oh, we got there in the end. Import string indexer. The string indexer, so if you're familiar with machine learning, machine learning algorithms don't generally understand strings too well, at least not for things like classification. So we're going to categorize them. And the string indexer is a class out of Spark that's going to do that for us.
In the meantime, I'm just going to reply to one comment. Born to be reborn. On your questions about jobs in general, like with anything, I don't know your definition about old, and I wouldn't actually question that in any shape or form. If you find something that suits your profile, please by any means do apply. We'll be more than happy to actually review that and actually schedule a phone screen, obviously, if we see it could work. But I don't think, like as people are actually saying on the comments, I don't think age has anything to do with proficiency or actually efficiency in that particular general. We can definitely have that discussion if you like. Feel free to hit me up on Twitter. We can have that discussion. My DMs are open. But I wouldn't try to have that conversation right here, especially because our shoes start to come up with this live coding episode. We're still trying to focus a little bit more on that. I don't know if it's just me, but continue to go. Sometimes I get confused with Jupyter notebooks. It can get quite not easily readable after a while, after a few lines.
Yeah, you're not wrong. It's got markdown support in terms of some of the cells that you can put in, but really could do with kind of some highlighting and color coding of some of the cells to help break it up a little bit. I've often thought that myself, having the ability to kind of collapse sections would be handy as well.
Mm-hmm. I think the main benefit for me is Jupyter. If you're watching this stream and never seen Jupyter before, Jupyter notebooks, is when you're dealing with data and you want to see how that data looks like, you want to manipulate data and see do things before you actually do. When you're writing a script in an IDE or something, you normally write everything and you run it and you see it, and then maybe that doesn't look like the way you want. And in Jupyter Notebook looks like quite interesting in that sense. It's visual enough for you to not only make codes and run that particular line only, but also for you to add markdown. That's exactly what some of the data science actually find helpful. Have something that anyone can run that particular code using what we call core or kernel in Jupyter terminologies. And that's actually quite interesting for actually sharing certain codes that are repeatable pieces of engineering from a data science perspective. Hello, Sengrup.
Okay, so just a quick bit of explanation about what we've just done here. So with this window class, what we've done is to define basically a select statement. And this is, the idea of windows is not uncommon to those who are familiar with SQL. What we're saying is that examine the data set based on the ISIN or the stock symbol. We want to order everything within a stock symbol by that date timestamp that we've just crafted so that they're in a sequence or in an order, but in an order by security or by stock symbol. Then what we want to do in the next line is we want to create a new column. This is that label that we were talking about. And we want to use the lead function to pull the next one in that sequence, in that date time sequence, by security, and pull it forward. So that's all we're doing here. It's a bit of kind of, I don't know, it's probably not an often used function maybe, but it's very, very powerful in terms of helping you to create both the training set, not just crafting the training set for training, but also creating that supervised training set where you need to engineer the label itself.
Right. Okay.
All right. So that's that. If we just take a quick look at what that looks like now and do head.
A number, right? Okay.
There we go. So if everything has gone according to plan, then we should see percent change and next percent change, which is not a number. So that's not good. It's worth noting that if you've got 5 rows of data and you then take a copy of those and shift them, you're going to have not a number in some spaces. Later on, when we use the linear learner algorithm, it doesn't like null values. So we're going to want to drop those. So let's do that now.
Interesting. So in the meantime, you're doing, does it break the whole algorithm or actually continues, but it probably doesn't train it enough?
It doesn't try to make an assumption about what it is that you would like it to do when it hits a null value, and so it just dies.
Gotcha.
Well,
okay.
It doesn't just die, but it doesn't complete successfully either. So.
Okay. I'm also conscious about time. We have about 45 minutes.
Okay. All right. Let's try to accelerate a bit then. So let's do features. df equals features dot drop NA in order to get rid of those NA values. And then let's also do features df equals features df dot select. And what we want to do here is the select is not only going to choose the columns that we want, but also the order that we want them in. When linear learner reads data in from S3, we're going to store it as CSVs, and it expects the first column to be the label for all of the additional observations.
Okay.
So all of the columns in the data, the 0 or the first column needs to be the label, and then everything else is the data that is meant to be used to predict that label. So we got to bring that next percent change forward and make it the very first column in that list.
So that's going to be next percentage.
Yep. So we want next percentage change and percent change. And then we also want plus number columns plus, we forgot to do the categorization. All right, so we will
I like that comprehension right there. Right, and at least comprehension live. You can't get more live than this.
the only way.
That's for sure.
Now that is going to break. So let's go in here and let's do.
And then you're gonna swap that piece.
Yeah. So let's convert those 4 column in string.
Okay, so let me send another link to everyone in case people couldn't join it. Previous links. If you joined just now and you missed some of the previous links, I'm just sharing those on the chat right now. I'm sharing one SageMaker orchestration that does very similar to what we're doing right now, except that it automates most of these pieces using CloudFormation, SAM, and a bunch of other scripts. And also sharing with you the data set that we are actually using and trying to manipulate right now. As actually, we're trying to filter that data out so we can go ahead and work with step functions, orchestrate the whole piece.
Right.
So let me share that with you for now. So here is the link for the whole project. Not this one, is another one which is more robust and actually even uses Slack to actually notify people that training has just begun. And you can actually go ahead and modify those as well. So so I can see that forward now.
So we've got that next percent change as the first column now. We've also, the line of code that I'd forgotten to put in was this categorization. I mentioned about the things like the ISIN, which if you remember, the ISIN originally is this very long string, which means something to a trading system, but very little to a machine learning algorithm. So we use the string indexer to basically turn that into a number, which is something that the algorithm can work with.
Yeah.
All right, so we've now explored our data set. We've figured out what sort of Spark commands or Spark code we need to have in order for our feature engineering. Let's now incorporate that back into our Glue job. And in the interest of time, since we've just covered all of this code, what I'd like to do is more or less just copy and paste in here. So hopefully everybody will forgive me for that.
That's fine. The only thing I don't forgive is actually the fact they're using Python 2.7. There, I've been waiting for that. So but everything else looks fine.
What we've just added is, we've added a logger, just because that's good practice. We still have our source bucket, our target bucket. You'll see here that we've also...
You're also hard coding Frankfurt. Line 33.
Thank you. EU West.
Ideally, that should be automatically picked up, right?
Yeah, and I'm not exactly sure what's going on there. When you instantiate the Boto Glue client, S3 works just fine. When you instantiate the Boto Glue client inside of Glue, for some reason, region doesn't get passed to it.
Oh, so it must be, because actually the way we picked that up is actually by looking at the AWS configuration or environment variables. So it has to be a default region. Yeah. If there's none, then makes sense. Okay.
Again, a lot of this code we've seen before, Glue context for reading the data, writing the data out. And then this is the code that we had in our Jupyter Notebook where we're doing the feature engineering, adding percent change, creating the next percent change, doing the string columns, converting those over to categories, and then doing the feature selection. What we didn't see in the Jupyter Notebook just now is this breaking out of the data set. So it's very common practice within machine learning to take the entirety of your data set, use some portion of it for training, use another portion of it for validation, and then the last portion for testing. What we're going to do is we're going to take 60% of our data set and store that out as training data. That's what the model will train upon. The validation, during the training phase with Stagemaker, it'll use that validation set to test that model after it's been performed, after it's been trained, and measure how well it's performing and see if it needs to revisit the training and reiterate over that training. Then that last 20% of the data, we're going to store out separately because, as I mentioned earlier, if as a part of our step function state machine, we wanted to evaluate that model and compare it with the old production model, that static training test data set would allow us to do that. So once we've got those stored out, we're going to write each one of those out to S3. We've got additional prefixes for the S3 bucket that we've put in here. So we're writing out to Eurex raw is where our data was going from the Deutsche Börse S3 bucket. And then we've got the transformed data, which is being given a Eurex data prefix.
Right.
This is important because later on when we see the crawler operate, it's going to create tables with names like data and raw.
Okay, cool.
One other thing to mention, this coalesce, if you're familiar with Spark, what that's going to do is reduce the number of jobs that can write data out. Without this, what you might see, and it might matter, it might not, depending on your use case, is you might see 0-byte objects in S3, and that's just the nature of the beast when it comes to Spark. Essentially, when it executes the job, it may or may not have data to work with, but this code still is telling it to write its data frame or its dynamic frame out to S3, so that's what it's going to do, even if it's empty. You could put logic in to work around that. What I've done is to use the coalesce function just to reduce the number of files that I get down to a maximum of 100, and that gives me a pretty good guarantee that all of them are going to have data in them.
Okay, interesting.
And then we've got this line here to, again, run our crawler when we're done. So let's take a copy of that. Let's go back to our Glue console. Let's modify our job.
By the way, before you ask anything on the chat, or if you're actually watching this live with us as well, you will see that most of these pieces we're using the console for now. And the reason for this is to make sure you can see that visually. It's not an easy concept to grasp at first, and that should at least help on some of those pieces. Using the automation would actually take the focus actually someplace else. So once we finish this episode, we're going to be still working on cleaning up some of those code, and then we will be open sourcing this. Right, so the job is already running. Okay, cool.
Yep, so while that's running, let's go ahead and, in the interest of time, get started on those Lambda functions. So Lambda functions are pretty basic. Most of them are about 40 odd lines of code, and most of that is just for formatting purposes in space. So let's jump over to the Lambda console. And we're going to need 4 Lambda functions. Avert your eyes while I specify 2.7 as my runtime.
That's fine.
Start glue job.
So just to let you know, in the interest of time, if you actually need to copy and paste from an existing one, and then we can walk through the code, feel free to do it. We're actually now about 35 minutes.
Okay. Tell you what, I'm going to let it create a new role for me from a template.
You don't need any permissions apart from just executing, right? Just transforming the data. You don't need to make any calls someplace else.
So the Lambda functions that we're going to create here need the ability to start the glue jobs and to start the SageMaker training job. So I'm just going to have it create a role for me, give it the permissions to write out the CloudWatch, and then I'll add the SageMaker and the glue permissions to it.
Okay.
All right, and I think we'll just use the microservice one here. Now, while it's doing that, let's go back to Glue.
You had Glue already open. Oh, you didn't. Okay. I thought you did, so just go ahead and open up a new one.
So jobs. Right.
Okay, succeeded.
Now, what's going on here? We've got some funky data. Not sure what's up with that. And then we've got data here. And actually, I think I know what's going on there. So we've got our data there, and that is the CSV files that we have written back out after we've done our transformation.
Mm-hmm.
So that seems to be running okay. That seems to be doing what we want. Let's go to IAM and let's revisit that Lambda role that we've just created. Right, and let's attach a couple of policies to this.
If I remember correctly, you need Stagemaker policy, and you also needed glue.
Yeah.
Okay.
I'm going to get a little bit woolly with this and just get overly permissive.
Yeah. But for the prototype and the time constraints we have, that's fine.
Okay. And we'll leave it at that. Okay. Okay, so let's go back to Lambda. And we'll do edit our start glue job.
Here we go. We have...
Yeah, we've got way more permissions than what we need.
Really interesting. Wow.
Way more permissions than what we need. Right, so over here, my code, I'm going to call this as handler. And what we need to do is to
okay.
All right. Tell you what, should we skip over this part?
Yeah, I would say don't worry.
Yeah. All right. So let's explore this in the console here. So what this Lambda function is going to do is very, very simple. It's going to receive the event that ultimately will come from step functions. And that step functions is going to specify the name of the glue job that we want it to execute. It's also going to specify those parameter values. So where we were doing -- date, -- sort bucket, etc., we're going to specify those in step functions. Our handler here is going to strip those out of the event and pass them to our start glue job function, which if we take a look at it, is very, very simple. It's a simple wrapper around start job run, a function out of the glue client from Boto 3. And to that, we're going to pass the arguments that we got from the event and the name of the job. Very, very straightforward. What we're going to do is capture the run ID of that job and pass it back to step functions. And step functions will use that after waiting a period to check on the status of that glue job.
Gotcha. Now things are making sense to me.
Yeah.
Okay. Cool. So that's the first Lambda function. Should we save and kick off the new one, or do you want to test that?
Let's do a quick test of it. We can let that run while we do other things. So sample event. All right. No, not there. So this is actually a copy and paste from the state that we're going to be initiating our step functions with. And again, it has the job name, which we need to set to be, I think we set it to auto trainer data lake job. Let's just check that real quick. Auto trainer transformation job.
Okay. In the meantime, we're doing so. Dumbbells. The reason we're using Python is because all of the libraries that we are using, like pandas and a bunch of others, actually are Python based, and we're also using Jupyter as well, which is actually a common practice to use Python. It is not necessarily a strict requirement. You could also write this in, let's say, Scala if you wish. The Lambda functions themselves, because they're acting more of a tooling around we need to orchestrate that job or start that job or clean up something very quickly, some data transformation if we actually need. In fact, you can do that in any language. All you need to do is, if you actually look closely at the code that we just wrote, it's actually primarily using AWS SDK. So you don't actually have to be constrained on the runtime that we are running. For Glue, on the other hand, then yes, you will need either Python or Scala. Lambda, like I said, you have Python, you have Node.js, Golang, Java, .NET, and more recently PowerShell. No problem.
Yeah, the PowerShell is a pretty sweet addition.
Yeah, let me say this straight. If you're up to a challenge, as soon as we open source all of these pieces with the code already cleaned up and actually more robust, including the cloud formation, the whole automation around these pieces, so you can just launch a new stack, we would welcome a contribution in any other language. So you could just make a PR, and we're happy to review, contribute, and have a discussion on that.
Cool. So what I've done is we've executed the initial job, the initial Lambda function, which is running the glue job. What we now need is a Lambda function to periodically check the status of that. So this is going to be very, very similar to the previous one. You could even make them the same Lambda function if you wish. What it's going to do again is to parse out the incoming event and pass that off to a worker function. And that worker function is pretty much a simple wrapper around the Boto3 client. Where the Boto3 client, we're going to use get job run off of the glue client. We're going to pass it the name of the job, the run ID that the first Lambda function passed back. And then we're going to interpret the results of that. So what we want to interpret is, different services have got different ways of describing their state. Some of them are going to say running in all capital letters. Some of them are going to say running with a capitalized R. Some of them might say not failed. It's not, there's no standard way of describing their state. But in terms of the step function state machine that we want to create, I don't want to be trying to figure out, is this one, are they doing all capitals for their running, or are they using just a capital R and then everything lowercase? So I'm going to do that standardization here in my Lambda function, have it interpret the service that it's communicating with, and then provide that back to something like step functions in the language that I've defined. So here you can see that I'm looking for all capitals for failed, stopped, succeeded, and then I'm transforming that into failed with just a capital F or completed with a capital C, and passing that back as a dictionary.
Right. Okay. Looks pretty straightforward to me. Okay. Do you want to test that, or happy to continue over?
So I'm happy to leave that as is. I trust that it'll work the way we expect it to. Let's now get into step functions. So what we've done is we've created a glue job, and that glue job will copy data from the Deutsche Börse S3 bucket. It will modify it using Spark. It'll engineer the data set and then write that data set back out as CSV into basically our training bucket, the bucket that we want to have all of our training, test, and validation data in. And the reason for that is because we want to pass that CSV data to Stagemaker for training later on. Now that we've got the glue job, we've created a couple of Lambda functions, one for starting that glue job and another one for evaluating the state of that glue job. And the reason for that is today, step functions doesn't have the ability to invoke glue jobs directly. So really, pretty much those Lambda functions are thin wrappers around glue that make them callable by step functions. Okay.
But continuing to go, one thing I have to say about step functions, which is actually very important. If you actually watch the previous sessions that we actually had on step functions not only will invoke a particular Lambda function, but actually can do a lot more than that. All the execution and control flow around, has that execution completed successfully? Has it failed? Perhaps was a transit issue? Should I run that again? Should I maybe catch an exception equals to a exception X, if you will? And you could actually retry to back off algorithm in there, actually add a probable, let's say a sleep 2 seconds or something. You could actually control all of this just by using JSON, or in fact, it's a code for a state machine in step functions. But essentially, it's very powerful for orchestrating pretty much everything. And it's actually very commonly used around microservices, those for doing a Saga pattern or pretty much anything that you need the orchestration piece. Do not ever, unless you have really good reasons for it, don't try to do the whole orchestration just by using a single Lambda function. Actually do rely on a powerful orchestration tool like step functions, because you have a lot more control for it, and you also have the whole execution history. You have all the pieces that you can do auditing to see who executed, when it was executed, what was the input and output of each of those steps, and a lot more that even though you can do some of that in Lambda functions, it's not going to be actually 100%.
Right, so if you recall, we had this pattern that we were going to use to start the transformation, wait for that transformation to execute, get the status of that, and then check that status. I'm just writing that out now real quickly as a definition of the state machine.
Okay.
Do we have time for this, or should we copy and paste as well?
I'd say we have 20 minutes.
Let's copy
so 23.
and paste as well.
For now, let's just copy and paste, and then we can explain that afterwards.
And again, as Later had mentioned, all of this is available as a GitHub repo online, so feel free to visit it. It's a lot more complex than what we're building here today, but it's a great example of what can be done all without creating a single server.
And I'm going to send that link once again in case people just joined it recently. And here's the link with a more robust continuous learning, and including Slack notifications and all that jazz, including the state machine as well. Okay. So if you want to take a peek at it, feel free to use it.
So just to quickly brief what exactly it is that I've pasted in here, we've got this initial task, the first step in our state machine, which is going to invoke a Lambda function. This isn't pointed at the right one at the moment, but it's going to be much easier to change that once I've got it in the editor for step functions. We're defining an input path and the result path where we want to capture the output of that Lambda function. You'll recall that Lambda function is going to pass back the job run ID from AWS Glue. We then want to have our step functions wait for a little bit, and that time is going to be defined by our input document that we're going to feed to step functions.
That's exactly the question I asked you before. You're actually injecting that dynamically. Okay.
Exactly. Yeah, it's that wait time is. It could be the output of a previous task, maybe the one that we just called, or we could even modify it periodically over time. So where that gives us capabilities right now, it's essentially a static value in terms of what we start the state machine running with. But again, that's something that could be modified by one of those tasks. So if we've checked it twice already and we want to kind of exponentially back off, we've got that ability to do that.
Okay, perfect.
Then we want to do that Boto3 call into getting the status and do that translation of running, succeeded, failed, etc. And we're going to look for a status in the next step of either failed or completed. And if neither one of those has come through, if it has neither passed nor failed, then we're going to go back to waiting. And then when that's done, we're going to mark the thing as succeeded.
Okay, just give it a name. Workflow.
Yeah.
And does I'd say let's fix quickly. Oops. Okay, cool. Yeah, we just need to fix those resources and those little errors. That's something I really like about step functions on the console. It actually still causing a problem there.
That's right. We'll come back to it.
If you click, you should be able to see a list, right? Here we go.
There we go. So here we want to do check glue job. And have you resolved yet? There is no error out statement. That's why it's angry. We'll come back to that.
And then that one too.
And then we want to start the glue job. Cool. Now we need that error out. So let's add that.
And by the way, if you haven't used step functions at all, on the YouTube playlist we have one last one called Breaking the Monolith, which we basically do, we get a monolith and we break into multiple functions and we use step functions to orchestrate all of that. All right. Okay, so just before I create a statement, do we have to do a refresh? Yes. This is something in case you don't know. You could actually, that's something I also leave as a tip. You could prototype using success and fail and choices and step functions, and you can visually see if what you're trying to make actually makes sense. And then later you can swap those success by actually calling a Lambda function or doing something else.
Yep.
Cool.
And
okay.
my favorite thing about step functions is you get a lot of great orchestration, a lot of great capability, and the ability to execute any one state machine for up to a year, and you only pay for when it transitions from one state to another. And I don't have that price memorized, but I remember it being minuscule, like gigabits per second with a Lambda function, where it's like 0.0001667 or something along those lines. So it's really, really cost effective.
Yeah, just be careful if you're watching this. Even though step functions allows you to wait for up to a year, not everyone actually likes to wait a page you load up for a year. So just bear that in mind.
So, all right, let's start an execution of this and just kind of observe how it goes.
Okay.
We're going to...
Actually, just before I do it, this IAM role that this step functions has, does that IAM role have permissions to invoke our Lambda functions?
That's a good question. We could check it, but let's just find out.
Okay. So that IAM at the S3 bucket, isn't that right? So our trainer that looks fine to me. S3 train URL is also different. What else? Okay.
This guy is probably not accurate, so we'll come back to that one. It's not actually going to use that training job data set just yet.
You have the target bucket as well, and the crawler, and the source bucket.
Source bucket's fine, date's fine. This guy needs to change. Auto trainer, transformation, job.
Mm-hmm.
All right, so let's try that out. Invalid JSON.
So let's see what we're missing. Do you want to copy that quickly to an editor? It doesn't... of course.
It's always the last bracket. Always the last bracket.
I'm yet to see some live coding not hitting the mark on white spaces, commas, and not closing a function or JSON or indentation in YAML. These are something that hits us. Whites is actually quite bad.
The worst is the blended white space in Python, where your indentation isn't quite what everything else is.
All right. Actually, I use black. I changed to black recently, and I definitely don't want to go back. Okay. So there's a plugin if you're using Python, if you're developing Python, there's a linter called black. That's my personal opinion, by the way. You could actually even have as a linter on your Visual Studio Code or any other IDE you have. Every time you save it, you automatically fix all the indentation or any other pieces that you have.
Okay. Now, while this is executing, one of the things that I really like about step functions is that you can not just graphically monitor what state it's in, but you can also look at what the input to that state was. So you can kind of track as your JSON document, as your state document gets modified.
Can you do me a favor, Jason? Can you actually close that on the left-hand side?
Yeah,
and let's just zoom in a little bit.
On the text document, on the JSON?
Yeah, just the text a little bit. Okay, here we go.
So, and this is all custom defined by you, right? So whatever your step function needs in terms of state and whatever values it needs, it's completely up to you how that document gets structured. And you can manipulate and modify it as the system executes, as the state machine executes, using some of those input and result paths. So you've got the ability to pass not all of this document, just a subset, and capture different elements of that document from the resulting executions and the different tasks that execute.
What I found interesting about your state machine, and that's something I don't necessarily see all the time people doing, especially in live demos, is if you go to your definition of your code, you had something about input path and output path. And that's something that step function is actually quite powerful on that as well. On the definition, yes, you see that on the top, the input path and result path. It's something that you can do that in step functions quite easily, and that's something very powerful.
Yeah.
Even if your state machine, the host step functions execution receive the entire JSON blob, you don't necessarily need to send the entire JSON blob to every single step out of the way. Yep. And that's a really neat way to actually do some manipulation.
While it's doing that, let's quickly create similar Lambda functions like we've done for Glue, but now let's do the same thing for Stagemaker.
Okay.
In the interest of time.
Sure.
We're going to interact with SageMaker in the same way that we interacted with Glue. We're going to use the Bowtail library to do a start training job and then to check the status of that training job.
Okay, so let me send you one piece here. If you're also interested in getting started with step functions and you never used that before, even though we actually, because we're time constrained, we only have about 15 minutes left. We're kind of rushing that for now, but I will send you a link right now that is very helpful for if you're beginning with step functions. We actually posted that quite recently. I think it's about a month old, if that. Where step functions gives you a few tutorials that you can play with, so you can get a hold, can kind of learn how the state machine syntax works, because we're primarily just copy and pasting for now. But that's actually quite interesting, especially using choices, understanding how to do the back off, dealing with exceptions type of thing.
Yeah, and you've got the ability to do complex and or type combinations as well as not. So you've got a lot of the traditional logic gates at your disposal. Now, just to explain very quickly about the pattern that I've just pasted into this Lambda function. Again, we're following that same pattern that we've done with Glue, where in our handler, we're going to break out that event object, extract from that the data that we need, and then pass that off to a worker function. So we're pulling out the training role that we want our training to be conducted under, what permissions we want SageMaker to have while it's training our model. We're going to pass it let me zoom in on these. We're going to pass it the training URI where our S3 data has the training data. We're also going to pass it the validation URI for where S3 is storing our validation data. Then we're going to pass it an S3 UI where we want it to write its output. When SageMaker is performing training, it's going to produce primarily two outputs. The first is going to be a log. And that log is going to be the traditional kind of log.debug type statements that you might see, whether you're using TensorFlow, your custom code, or even the linear learner or the algorithms that Amazon SageMaker provides for you. It's going to produce log entries. And if you need to start to troubleshoot or understand maybe how the weights and the coefficients developed over the epochs in the training, you can do that by digging into those logs. And those are written out to S3 as a part of the standard output of a training job. In addition to that, and perhaps more importantly, all of the weights and the coefficients and the trained model that results, the network that results from that training, is also going to be written out to S3. If you've seen any presentations on Amazon SageMaker, it's worth noting that SageMaker is a lot of individual services. One of them is training, one of them is hosting. You've already seen Duplin Notebooks. And they can be used either altogether or individually based on what your use case and what your requirements is. So the reason that training job is going to write that data back to S3 is maybe we want to take that network, we want to take that trained model and maybe run it as part of a smartphone or a mobile application, or maybe run it as a Lambda function, or maybe even just run it on premise or even with a Hadoop cluster. We've got that option available to us. There's no lock-in with Amazon SageMaker.
Cool.
After we've extracted those features from the event, or rather those parameters from the event, we're going to pass that off to our worker function. And that worker function looks more complicated than it is. It's going to create a name for our training job. It's going to specify the container that we want SageMaker to use for training. This is how SageMaker is able to support not just things like TensorFlow and PyTorch, as well as the SageMaker algorithms, but also can support any Docker container that you can provide to it. So if you've got completely custom code that you want to train or even host on Amazon SageMaker, you've got that option to do that, as long as you can wrap it up into a Docker container.
Just before you go, is that region correct? You're going to use ECR?
That is absolutely incorrect. Thank you very much. So where did we get that from? We didn't actually load that up. Let's do that now.
Interesting. I didn't know that was actually available. Cool.
No, that's not it.
So what are you looking at? You're looking for the Docker
ECR.
Okay.
Yeah, so there is, here we go. This is what we want. So there's 14 different Amazon SageMaker algorithms that are provided out of the box. These are what customers tell us they use most often. And again, they are Docker containers. Now, there is the SDK for SageMaker, which makes this a single API call or a single function call. I didn't take the easy route on this. So what I need to do is to take, for the linear learner algorithm, which is what we're using, take the path for EU West 1, which is right here.
Right.
And paste that into my code. Again, if you were doing this in Anger, you'd probably create a map or something similar for doing this. Do it a little bit smarter than what I've done right here. All right, so that's now accurate. Now, this long list of parameters, this kind of bit of code that makes it look so confusing, is pretty much copy and pasted from the Boto 3 homepage. So if you go out to Boto 3 and look up Stagemaker, I think I've got that here, you're going to see that same request here. Trust me, copy it, paste it, and then tailor it to your use case. Don't try to write it from scratch. Okay, so that should be all good. What this is specifying, just to walk through it very, very quickly, is we're specifying that container, our algorithm. We're specifying the IAM role that we want it to execute, where we want it to output the data to, what instance type we want it to run on. That can be an M4, it can be a T2, it can be a P2 or a P3, so we've got access to GPUs if we want them. How many of those we want to train on, and how much disk they're going to need, and that's going to be important for the data set. Then we're going to specify the location of our training data, which again we passed in as parameters. Those are the CSVs that we wrote out into S3 using Glue, and that's as a CSV. And then equally for the validation, the URI for the validation data. And then after that, we're just going to do create training job and pass it those training parameters and read the job name that comes back in the job ARN. And then we're going to pass that back to step function. So I'm going to click save on that.
Okay.
All right, and then we need to create one more, which is going to just check on the status of that job once it's running.
Cool. One piece I have to ask you, Jason. So if you just copy and paste on that one, and then we skip the explanation about the code itself on the check training job.
All right.
I just want to check on the state machine, just to make sure we can finish on time.
Okay.
And then if time allows, then we can just go back and explain the check on training.
Yeah, absolutely.
So change it to handler and cool.
Okay.
Awesome.
Right, so let's revisit step functions, and now we need to plus up our step functions. Oh, failed. That's no good.
Isn't that because the functions weren't run ready yet, or actually no, something else? Let's have a look what it is. Output. What was the output of that? Exception? Oh.
Calls could not be determined because Lens did not return an error type. Interesting.
Okay. We actually have access to the CloudWatch logs straight there as well. But if you want to create a new one for now, just to see if that works.
Okay. Yep. So let's go to definition. Let's edit this.
And then we can go back and try and troubleshoot that quickly. All right. So in the meantime, let me send something to people, because that I found really interesting. The exception that we've just found now in the console, we still need to troubleshoot that. Why? I sent you a link on the chat. That's something I found out recently on step functions as I was doing it under the demo. On that link, you will find something, not only the states.all type of exception that you can do in step functions, which means if any sort of exception happens, you can actually catch that and do something else. Let's say next, retry, or something. Sometimes Lambda or any other AWS service or any other distributed systems could also have transit issues. That could be networking hiccups, or could be anything in general. The link I sent you, there's one is particularly for Lambda, which can be quite helpful. So if your Lambda times out or whatever else happens, that's something that you're not expecting at all, you could actually also catch that, particularly to your code or to the particular execution context of Lambda. So have a look at that link. That's something that should be a best practice for you to apply to. Right, so how are you going that one? So I saw you got a new definition for step functions.
Yep. So we've got a new state machine defined. I'm now just going to create my input document, and then we will get this launched. So let's take a look at the previous job where we already pasted our job definition.
Okay, so do you want to copy all that?
Yeah.
And then, okay, easy.
Okay. And let's
So you can
start
go
a new
back.
job going.
Mm-hmm.
Now, the one thing I'm going to need to fix is this guy right here.
True, I actually have forgotten about this one.
Okay, we should be okay.
Is that the right account? Yes.
It is, yeah.
Okay. Right, so have a look at that. Oh wow, that's much bigger than before. Can you? I think you can go full screen on that one. I
Yeah.
think there's a button in there. Yeah. Yeah, then you can just zoom in a little bit. Here we go. So if for those of you who are we only have 4 minutes left, but in the maybe we won't be able to finish every single step. Every green that you see is something that succeeded. The blue one is still in progress, obviously, and that wait for transformation and the whole check and wait again. We instead of actually hard coding the wait state, we're actually injecting that dynamically. So that's something you can do too. And then I start training, for instance, all that get training status. All of these are individual Lambda functions that Jason actually broke that down previously, including the get transformation status. One of the nice pieces about all of these arrows that you see in circle coming back in, this is actually when you're trying to capture this output and state and say, well, we're now ready to proceed. That's actually back up again. So think about something that you're working with AWS batch or something that's long running and you want to go back and forth to say, well, it's not ready the job yet. Mm-hmm. Let's go back, wait a little bit more and so forth. So that wait is actually waiting on step functions and not Lambda. So it sounds like we failed again. Let's have a look at quickly, or do you think?
I think we've got 4 minutes left, so we'll just note that live demos are subject to failure. Murphy is alive and well. But let's highlight, just as you walk away from today's session, first, thank you very much for joining us. I would invite you to, while this code isn't open sourced yet, it will be shortly. In the meantime, available on GitHub today is this code, which again, Hader sent out the link for in the chat. And it's going to have a very, very similar flow where it's going to be pulling data from S3, running a training job in Stagemaker, making that notification into Slack so you've got that two-way communication going back and forth. So I would invite you to go ahead and deploy this into your account, or at least have a look at the source code and get a feel for how it's operating and see if you can't use it for your own purposes.
Awesome. And by the way, if you can stew actually in 15 minutes time, we also have Nikki and AM talking about the front-end development on AWS using single-page applications. In fact, it's actually a pretty cool workshop. I just had a quick look about an hour ago, and I would definitely recommend for you if you can stay, watch that, and it will be awesome. Learn some few new tricks as well. Jason, thanks so much for coming along.
Thank you very much for joining us, guys.
Yeah, and as soon as we actually have the link open source with the whole automation piece and something that you can reproduce yourself, we'll be actually sharing that either on YouTube as a comment or actually on Twitch as a comment as well. Cool? Perfect. If you need to catch us or do something or want to catch up anything you like, feel free to hit us on Twitter. I'll get your Twitter handler because I think we didn't include that first on the lower thirds, but that's something else. Thanks for watching, and I see you soon.
Thank you very much, guys.